Hello, welcome everyone, and thank you for joining us for today's webinar on what's new in OrCAD X 24.1. Now, before we get started, I'd like to cover just a couple of housekeeping items. First of all, as you noticed, your lines are muted when you join this webinar, and they will remain that way for the duration of today's session. We are recording this session, and it will be link will be sent to you probably in the course of the next week or so. During the webinar, if you have any questions, please send those to all panelists in the Q&A box. There's a chat and a Q&A, so please send questions to the Q&A. In the chat, you'll notice that I've shared, excuse me, a link to an OrCAD X free trial. So if you're interested in that, please check that out. My name is Supreet Manava. I am the host of today's session, and I am a product manager in the PCB division here at Cadence. I'm joined by two of our product engineers for OrCAD X, Nitin Thapliyal and John Carney. Today, we're going to be taking you through some of the key features in OrCAD X 24.1, and you'll mostly get some demonstration here. And towards the end of the session, we'll have time for Q&A. Now, many people approach us and ask us, what is OrCAD X and how is it different from what you know as OrCAD if you've used OrCAD for many years? I think the best way to represent this is captured here. The central themes of OrCAD X is that it is meant to design fast, design correct, and design connected. You can see some of the reasons that we put under each of these different categories as to why OrCAD X accomplishes those key focus areas. For example, under design fast, you have the ability to quickly create footprints, and as a user, maybe without tons of supporting librarians or something that you might have in an enterprise setting, you can quickly get up and running with a library in OrCAD X. Designing correct, especially in the last few releases over the last couple years, we've added topology exploration and extended the InDesign analysis into OrCAD X. And then designing connected, as you all probably are facing the challenges of the modern demands of PCB design. You'll know that having connectivity to adjacent domains and even from an engineer to a PCB designer into the MCAD domain, all that stuff is very important for today's electrical engineers and PCB designers. So this is the vision that we have for OrCAD X moving forward as well. Now with that, Nitin will take over here and present some of the key features from OrCAD X Capture.
Thank you, Supreet. So I'll share my screen. Okay. I hope my screen is visible. And okay. So good morning and good evening, everyone. And today I'm going to quickly give you an overview in our demo on the enhancements and features that are done in the 24.1 release of OrCAD X Capture. So I'll start with LiveBomb. So I have the sample design open, and I'll launch LiveBomb on this. So here I see all the components, and I see for each MPN associated to this component, we get the supply chain information. So I'll select a MPN row here. And here I will see the information about this manufacturer part number on the right-hand side and the alternate suggested by source engine on the bottom section. So now in 24.1, if we focus upon the top right corner, we will see an icon with the tooltip as forecast. So with a component row selected, which has an associated MPN, I will click this icon. And once clicked, we will see that at the very bottom panel section, we will have supply chain forecast tab show up. So this tab shows the graphical charts for the supply chain information for the associated MPN. So here we have lead time, inventory change, price change, and market availability for the associated MPN. So this includes both the historical and future supply chain trends. So in the forecast section, which is on the right hand side here, we will see that in addition to average graph, which is the blue line, blue graph, the forecast data also shows linear graph for high and lower bound limits for the forecast period specified. If I hover my mouse over any of the data points, I will see additional details about it. So for instance, I have hovered my mouse over a particular data point which is in the past or history, and it shows that in the week of August 4, the level or the basically the lead time was 19, and its previous data point value was also 19. So hence the delta and the change is 0, which is basically the difference between the two data points here. And if I hover my mouse on the forecast section, here I will see that in the week of November 24th, November 24, 2024, I see that the lead time would go up to 22 weeks. Similarly, I can view the forecast data for both inventory, market availability, and the price change. On the right-hand section, we would see additional details. So here on the general section, I have the start date from where the forecast timeline begins. Then we have the look back period, which is the duration of the historical data which is being viewed in the graph. And then we have the forecast timeline. Below it, we also have the forecast data for the very last data point in the forecast section. And this shows the lead time high, average, and low for the very last data point, along with the trend. And I can also change the duration of the look back period and forecast timeline from the drop down here. So let me change the look back period from 3 months to say 12 months. And once I select this, I would see that the graph would get updated with the details on the history section. Now, similarly, I'll select the forecast timeline to year, and here I will see that the graph also gets updated. Okay. So based upon this information, user can ascertain whether the MPN which is being used is okay for rest of the life cycle of my design. So with that, I complete the lifetime portion. So I'll close this, and I'll close this project. And now I'll move to the next update, that is in the file manager. So I'll launch file manager, and this is currently I only have my local workspace, so I see it here. So let me expand this, and I'll select libraries and the PSpice models folder in my local workspace. So new enhancement in file manager is that now I can upload the data to my workspace from within the UI itself. So let me bring up local folder location on my PC. So I have these multiple PSpice models. Okay. So in order to upload these to my workspace so that they get synced with the cloud, all I need to do is select all these files and simply drag and drop them in the UI. So these files would get uploaded to my workspace, and within a few seconds, they would get synced up with my cloud account. Okay. Similarly, if I want to bulk upload multiple folders to my cloud workspace, all I need to do is simply select a parent folder here. For example, if I want to upload multiple projects, so I'll select this projects folder here. And at the very top, we have this new add new button. So I'll click this, and this would bring up some additional menus here. So here I'll click upload folder menu, and this would bring up the browse for folder dialog. And then I'll browse to the directory which has multiple projects my end. So this is my projects which has multiple projects. So I'll select the parent directory and I'll click OK. So once I do that, the selected projects get uploaded in a single. So using these, now I can, from the file manager UI itself, bulk upload file as well as folders in my workspace area and sync them with my cloud account. The next enhancement that I'm going to talk about is the updates in the workspace configuration dialog. So I'll open the workspace configuration dialog. So you can see that the UI has been updated. Okay. Now, for each workspace that we see here, we additionally see information regarding its data residency and domain. So data residency is basically the location where this server is located. And it is due to the data protection laws which a particular organization or a company requires, where for privacy and security, we generally opt for a server which is located within their country. So now, at the time of creating a team workspace or shared workspace, user can opt for a server location. Okay. And on the last column, we have the domain column, which basically specifies as to whether this workspace is external or internal. So if a workspace is internal, which it means that it would be accessible by all the users who have the same company domain. And if you want to create a workspace which needs to be accessed by a person who is outside your organization, or suppose say your partner, which who has a different domain, then you can create an external workspace. So now here I will quickly show a demonstration of as to how to create these workspaces. So for that, this is we see this new workspace button here. So I'll click this, and this would bring up the add workspace dialog. So I'll initially create an internal workspace. So I'll give it a name and a description. I can specify the data residency or basically the server location. So I'll let it remain as USA. Then we have the assign roles and access section. So now we have this default role field, which specifies that at the time of creation of workspace, I can specify all the users who get added to this workspace what kind of default role that have. So once a workspace is created and each user is added, so by default, I can now specify what default role that user will have. So let me select design and librarian. After that, we have a radio selection for whether this workspace needs to be accessed by only specific users or all the users who share the same domain. So I'll select all user in organization. So by selecting this radio button, I will ensure that once this workspace gets created, all the users or company team members would have access to this workspace. So with that, I'll click OK, and this workspace gets created. So once this gets created, you can see in the shared with section, I see asterisk marks followed by the company domain, which indicates that now this workspace is accessible by each and every member in my organization. Over and above this default role, if I want to specify some additional privilege to a specific user, all I need to do is specify his email ID. to add him in this shared workspace. And then I can, and we see that the default role that we specified at the time of creation gets associated. So if I want to override it, all I need to do is just from the drop-down selection, select a different role. Okay. Similarly, now let's create a new external workspace. So let me name it one. And now this time I'll specify its data residency as Europe. Okay. I'll let the default role remain as viewer. And I'll select the radio button, let it remain as selected user in organization so that it is accessible by user who I add on my own in the shared with section. And I'll check this checkbox so that it becomes a shared box, an external shared workspace. So by checking this checkbox, it ensures that this is an external workspace, and I can add users who are outside my company domain. So with that, I'll click OK, and I see that this workspace gets created. So now let me add a user who is outside my company domain. Okay, and I'll click OK. So once I click OK, these shared workspace, it would start to appear in my file manager section here. So other update is that now I can publish, or basically I have the common to use operation directly available on the left hand side tree. So if I want to publish a particular project, all I need to do is just select that project from the left hand side tree, and I can get the basic operations here. Okay. So additionally, I have another machine where I have logged in with an email ID for the user who I added in the external workspace. So I'll just bring his configure workspace configuration dialog here. So this is the shared workspace that we created just now, and this is the user who is currently logged in this machine. So if he launches his file manager, he will also see the external workspace that we created on the first machine. So with that, I complete the data management and workspace configuration enhancement. So I'll close File Manager, and now let me quickly cover the enhancements in the PSpice. So I'll open a PSpice-based project. So the new feature in PSpice is that now with 24.1, there is support for .measure commands in PSpice, and this is supported for all PSpice licenses. And here I have a demo circuit, which is basically an amplifier using BGT. Okay, so and I have this text file which has where I have specified using the measure commands various parameters. For example, I have created a measure command to measure the peak value, quality factor for this amplifier, and peak frequency for a particular traces. So all I need to do is create a measurement, specify the parameters, and once done, I will all I need to do is save this file as a include file with .inc statement extension. Okay. So once this is saved, I will open my simulation settings and include this uh, measurement file that we just created. and I'll click OK. So I see this gets added in my PM tree. Now I will simulate this circuit. I have the results. All I need to do is go to the file location where these results are generated. So I'll go to File, Open File Location. And I say this AC_measures.txt file. So this is the output, which is output text file, which is generated based upon the include a file that has the measurement expression. So if I open it in text file, I will see the corresponding results of the expression or the measurement that I specified. So with that, I complete the enhancements updates in the OrCAD and PSpice for the 24.1 release. I'll hand it over to John for the rest of the section. Thank you.
All right. Hello, everybody. This is John Carney, and I'm going to be showing you the new features in OrCAD. The first new feature I want to show you is this new constraint panel. This is going to be available in the first ISR that's coming out in 24.1. So the objective with this constraint panel is constraint-driven design has always been a powerful feature of the OrCAD platform, and now we're making that power very easy to use. So the idea is you have your design open and you want to start to apply constraints to the nets in your design. So now, without leaving the context of your design, you can switch to this constraint panel and you're presented with the constraints in these different categories: electrical, physical, spacing, and same net spacing. The way we always prescribe to constrain your design is to think about creating rule sets and then assign those rule sets to nets in your design and then begin routing. The last thing we would ever suggest you do is to, on a net by net basis, go through and start typing in, I want this net to be this wide, I want this net to be this wide, because that's just a waste of time, right? It's much more efficient to spend a few minutes first thinking, what are the different types of nets do I have in this design? Power nets, high speed, diff pairs, every other net. Create the rules that you want for those nets, and then assign those rules to the nets in the design. And then once you do that, as you're routing the design, the route engine will always route and adhere to the constraints that you have set. So here's how you would go about using this. So in each category, there are basic rules and advanced rules. Under physical, you can see these are the rules that already exist in the design. If you want to create a new rule set, you can hit that plus sign, and then you've created a new rule set. Once you have that rule set created, you can then specify, using these interfaces, the basic physical rules. What is your neck width? What is your minimum line width? What is your max neck width constraints? And for your differential pairs, what is your neck width and min width and gap? What vias do you want to use? And if you want to create a new via, you can hit this create via button and you can create a new through hole via right there. And that will get added to the list of vias that are being used for that net. Once you've created that rule set, you can then select nets in your design and assign that rule set to those nets. So that's how the workflow works. You create rule sets, assign rules to nets, buses, or you can even put nets into groups and assign them at that level. So the physical rules give you basic physical rule spacing. And if you're doing a basic design without a lot of complexity, this may be all you need. Under spacing, you also have a basic and advanced area. Same concept with the rule set. And under spacing, you then have your pad to pad, line to line, pad to shape, line to shape, shape to shape. spacing values. You can, with the physical and the spacing, you can set these rules differently for all layers, internal layers, or external layers if you would like. You can also tell the tool which rules you want to have enabled or disabled. So for example, let's say you don't want to check certain rules, you can turn them all on or all off, or you can go into DRC modes, which will then open up another window where you can explicitly go in and specify different spacing rules, which you may or may not want to check for. So those are the basic spacing rules. Very straightforward. You have the exact same thing under same net spacing, which out of the box, we turn off same net spacing rules, but if you want to check these things for same net, you can do that as well. For electrical, under basic, you have just basic rat's nest scheduling rules, total etch length, and maximum via count. For basic designs, a lot of people tell us that's all they really ever need, so that's why we broke this out into a basic and advanced. Now let's pretend you have some more advanced requirements. Then you can just switch over to this advanced tab. Now you have the same rules, but one level deeper of fidelity of control of what you can control. So now, for example, under layer type, you get this window here where let's say you want to explicitly set a physical spacing rule for only your ground and power layers. You can do that by toggling on and off these layer selectors here. Now under line width, you have neck width, min width, and a maximum width. You now also have some via controls as well, what your blind vary via stagger is, where you want to allow pad to pad connections, if you want to allow etch on the layer at all, and where you want to allow T connections for these particular nets. You also have advanced differential pair spacing rules. So you can set up the physical requirements for differential pairs, and you can also set up things like static phase control and dynamic phase control and max uncoupled length. These two phase control rules are going to set and control and check if you have a diff pair that's in phase. If it comes out of phase, how long can it be out of phase before it has to become back in phase? And that can be done dynamically or statically. So the advanced physical rules give you one more level control of physical constraints. Same thing with spacing. When you go to the advanced spacing rules, you still have the controls for all different layers. And now you have more advanced spacing. So you have via pad, line, pin pad. So now you have separate spacing rules between a via and a pin. And you can also go explicitly into pad shape spacing and have explicit spacing rules for a through pin, a blind buried via, or a through via, or a micro via to all other objects in design. And then you can also specify your spacing from holes to different objects in the design, or different types of holes to different other holes in the design. And so we basically designed this so if you need these rules, they're here for you. If you don't need them, you would just turn off the DRC mode and you don't ever have to check them or worry about them. We go into the electrical advanced. Now things get pretty exciting under electrical. Now you have access to the diff pair rules, which are a copy of the physical rules. The reason we offer these in both locations is some people think of these things as they're defining the physical parameters, so that's where I want to set them up. Other people think of them electrical. We couldn't decide who wins, so we put them in both spots. You then have the ability to create delay rules. You can set up or create pin pairs and specify minimum and maximum delay, and also relative propagation delay. If you want to set up relative propagation delay rule in the design, you can set that up. And then when you set up the relative propagation delay, you can see which nets are in the group, where the target net is, and if the target net is longer or shorter than the other nets in the group. You can also set up return path, where you can specify a net needs to have a certain reference net, what layer that reference net needs to be on, and how long that net can go without a reference before you get a violation. And then you can also set up single line impedance rules. If you need to go one level deeper, then you have access to the constraint manager that has all constraints. And for electrical rules, you can also launch our topology explorer tool, which will let you build topologies or extract topologies from the routed interconnect on the design, simulate, model, and create constraints with that. So that's the new docked constraint panel, which should enable you to create constraints and use constraints much, much faster. Next, I'm going to show you the new footprint generator. This is accessible under the File menu. So under any File menu, you can do File, New, Template-Based Footprint. And what this gives you is it gives you a library of several different types of standard PCB footprints based upon IPC. So you have area array, chip arrays, discrete components, lead components, chip carrier components, all sorts of different components, through hole, axial lead, right? Every single type of model is going to give you a nice graphical representation with parameters that you can use to generate the footprint. So once you find the footprint that you want to create, you generally would pull up your data sheet, and these parameters here generally reflect the exact type of parameters that you would see. So you would have number of pins in the X direction, number of pins in the Y direction, XY pitch, package height, standoff, terminal diameter. If we were to go into, let's say, a quad flat pack, then you have more different types of parameters that you can use and generate. So once you find the type of device you want, you would come in here and you would vary the parameters that you want to have generated. And then you can specify whether you want IPC A, B, or C, and then you hit generate. Let me find a part that's going to have a little more some variety to it with respect to the, there, we'll choose this part. So if you were to then choose this part that you want to generate, you go ahead and hit generate. That's going to take all those parameters and generate a PCB footprint for you. The PCB footprint gets generated. It creates the pad stacks that you need. It creates all the boundaries like the place bound, keep outs, keep ins, everything that is needed for that IPC symbol. You also get a 3D model of that PCB symbol that now you can be using for 3D checks. And then now that you have this symbol in place, the symbol knows that it came from a template. So if you have generated this one day and then you want to modify it, you can come in here and modify it using the editor, or you can use this refresh button and then it throws you back into the template. You can then modify these parameters however you want and then regenerate or update the footprint on the fly. So with that, you're going to have access to hundreds of different types of parametric footprints that you can generate on the fly. So now changing gears. Through talking to our customers and designers, we're very aware that in PCB layout, you spend most of your time routing, and then the second largest time sink is placement. You're moving components around all the time. So we aspired to give you an industry-leading placement and move command. So to access that, you can hit the move command, and then now you have this move command over here. And you have a couple of different controls. First, you have the ability for traces, whether or not you want to rip them up or slide them. So if you're in slide mode, when you pick a component and you go to move it, it's going to slide those traces around. If you go to rip up mode, you pick up that component, it then rips up the traces at their previous intersect. Another thing that we've heard is that, some people like to have their commands over there. Some people don't want to move their mouse over there. So with this command and with every command in Presto, you can summon those commands right to your mouse, toggle them the way you want, and then hit your X key and it'll put them back into that floating command window. So you can do that with every key. Just hit every command, just hit your X key, you get your command parameters, hit your X key again, and it moves them over there. The next thing that we're going to show you is the display that you get. So normally when people are moving a component, they are keenly interested in where that component is and where that component was. So as soon as you pick up a component, you get a heads-up display. The heads-up display is telling you the XY location, since you are in absolute mode, the XY location of where that component was, and then as you move the component around, you get the XY location of where the component is going to be if you choose to drop it down at that point. So if you choose to drop it down there, then you know where it is at based upon that XY readout. Let's say you want explicit XY coordinates. So if while this thing is attached to your cursor, if you hit your tab key, you can now type into these fields. So you can type in 95, hit tab again, type in 45, and then hit enter or your left mouse button, and it'll then drop the part at those XY coordinates. So what that's giving you now is an ability to see where it's going and see where it was, and then type in explicit values of where you want that thing to be. So that's how you would use it if you have explicit XY coordinates that you want to place things. Now, let's say you want to place this component relative to something else or relative to where it was at. Now, when you pick that part up, you get the original XY location, and now you get the DX DY, the distance from where that component was. Same as before. If you type in the tab key, you can now type in relative values. So you could say, I want this thing to be minus 0.5, and it's going to be minus 0.5. So now you have a relative distance control. Other situations, you want to have this part be a certain distance away from some object on this part. That's when you would use this pick relative origin. So I'm going to pick up this part here. Actually, I'm going to pick up this part. Notice that as I'm moving around, you have that kind of second cursor. That is the snap cursor, which is another new feature. The snap cursor is telling you where you're going to get, what point you're going to be picking this object up from. So right here, you can see in the bottom right corner, it's telling you that it's picking it up from the edge vertex. Here, you're picking it up from the pin. Here, you're picking it up from the symbol origin, okay? Here, I'm going to pick it up from the edge midpoint. So I'm going to pick that component up from the edge midpoint and start moving that around. And if you want that component pickup point to be a certain distance from a part on this component, you can choose pick relative origin. Now the command is, the tool is asking you for a relative origin. So right now the origin is here. It's where that component was. If I pick here, now the relative move origin is based upon that second pick. So now I have a display telling me how far away that edge of that component is from the edge of the other component. And you have a nice readout. And then again, you can type your tab key and put in DX or DY 0, boom. And now you have that exact spacing that you wanted. Additionally, you can turn on alignment guides. Sometimes you don't care where things are at, you just want them lined up. So if I were to turn on some alignment guides, now I can turn on these alignment guides and just use that to line these things up horizontally or vertically. If you want to turn on and off that snap point, you can do it from here. And let's turn on the grids for a second to show you the last option. Sometimes you may want to have components placed on a grid relative to a pin or a bunch of pins on a connector, for example. So if you want to turn on a temporary relative grid, you can turn on a temporary relative grid, pick an origin location, such as that pin, and then type in a relative grid. So now you have a grid at a certain spacing where the origin of that grid is based upon a pin that you picked. So now when you're moving components around, you're using that temporary relative grid instead of the grid that you're working with for the rest of the design. So that is the new move command. Hope you guys like it. The next feature is a subtle feature with display. PCB designers are visual. Everybody's a designer. And this can help a PCB designer. It can also help a person who may not be the PCB designer, but just needs to look at the design for a review and markup type of perspective. So let's say you're looking at this design, you didn't do it, and you want to know, where's this data bus go, right? So you can come over here, you can select that data bus, and you can see that it kind of highlighted the bus in the design. So it is highlighted, it is selected, but it's still a little challenging to see where is that with everything else in the design. So we're giving you two new controls down here. One is a way to toggle through different shadow modes, and another is a way to see the nets based upon a color that's been assigned to the nets, or the colors based upon the layers that those net objects exist on. So if I were to toggle that shadow mode to mid, now you can see everything else that's not selected still has its colors. And now you can see that the net is highlighted. That's the red color you're seeing. And every other color you're seeing is showing you the layer that that selected object is on. Maybe that display works for you. Maybe it doesn't. If you want to see it even more vividly, you can turn the shadow mode on to be full shadow mode. So now what that does is it makes everything that's not selected completely gray. And now you're seeing the net in its assigned bus color. So I've colored every net in that bus to be this light blue color, right? If I wanted it to be a, let's say, a yellow color, you could do that. So now it's showing you that net in that yellow color. So now it really stands out. But what if you're still thinking, gosh, I want to see what layers those things are on? Then you can turn off the assigned net colors. And now you're seeing the selected objects with the colors that those layers are on based upon this matrix over here. And everything else is grayed out. So that can be very helpful in a couple different ways, depending on what you're trying to find and figure out. Another example of that would be, let's say you colored this 1.2 volt net orange, right? So you select that and you can kind of see where it's going. If you turn on mid shadow mode, that gives you a better idea of how it is with relation to all the other power planes in your design. If you turn it out all the way, now you can see this is a very good design review method to find out, are there any pins on that 1.2 volt net that aren't in that shape somewhere, right? If there was some pin somewhere else, then you have to work on your power shape pouring a little better. And if you want to see it from the layer-based colors, you can turn that on, and now you can see you have a, one part of that net is a big shape on the top layer, another big shape on an internal layer, and there's all the pins. So that's the new display mode. Next, I'm going to show you two InDesign analysis workflows. These were made available late in the 23.1 release cycle and fully productized in 24.1. So what you can do now is under View Panels, you can turn on the analysis workflow, and you have access to two different types of analysis, impedance and coupling. Under impedance, you basically work your way down this workflow. So you can do it based upon nets or directed groups. I'll show you directed groups when I get to coupling. And for the setup, all you really need to do is select the nets that you want to analyze in the design. And you can choose to do the entire design or just specific nets. And then you have some electrical rule check options that you can configure, such as cutting parameters, simulation parameters, electrical models, field solvers, things like that. For impedance domain, you can typically use the out of the box. And if you even want, you can do a cutting area around specific nets and then just hit start analysis. For a design of this size, the analysis is going to run in maybe under 5 minutes. So it's not going to take very long to run. Once the run gets completed, you can turn on impedance vision. Impedance vision is now going to show you, it's going to color code all the nets in the design based upon the range of impedance values that you see. It doesn't mean blue is good and red is bad. It's just red is the highest, blue is the lowest. And if you really want to see, like, well, show me everything that's higher than 60, you can put that display up there, and now you can have a better visualization to find where are the segments in your design that have an impedance higher than 60. What could be causing that, right? Maybe you're the person who designed that and you know that there's some voids and planes, for example. And you can look at that in terms of single-ended or differential. So if you do differential, now you can very easily visually see what are the impedances of your diff pairs in your design. What range are they in? So visually, you have a way to just visually inspect your design. And since this is still the full layout editor, you can very easily turn off the impedance visions or keep them on, go into the slide commands, start sliding and reworking your design, and then rerun the analysis and see if you still have the same problems. So it's a find and fix type of solution. If you want to go one level deeper, you can also look at these impedance tables. So if I were to look at impedance tables from a single-ended perspective, you now get this table over here, which you can dock on the right, you can dock on the bottom, you can dock it wherever you want, you can dock it on a separate monitor. I prefer the right over here. And what this will give you is it'll give you a summary value for every net in the design, the number of vias, the number of references, max, minimum, typical impedance, the length of the impedance, max, minimum, and typical, and then the delay, resistance, inductance, and capacitance. So let's say if you want to use this to find where the max impedance is in the design, so you can sort by max impedance, and you could select a net. Once you select a net, it then breaks that net down into all of its different segments that have different impedance values. So you can see that particular net has an impedance range of all the way from 40 all the way up to 78.9. Typically, it's around 40 to 50, so maybe that's not bad, but this little segment here might be a problem. So you can double click on that there. It takes you right to where that segment is in the design. And now as a designer, you can work on fixing that. What is causing that impedance value? Maybe there's a void in the reference plane. Who knows? But now you can work on finding and fixing that if indeed that is going to be a problem. The second workflow is coupling. Coupling you can kind of think of as crosstalk, but much easier to set up and run. With crosstalk, you need to explicitly assign IBIS models for drivers and receivers, set up timing windows. If you know all that information and have all that data, that's great. If you don't, most designers would tell you that if you're running a bunch of traces parallel to each other for a long length, you're going to have a crosstalk problem. So if you think of it from that perspective, the coupling workflow allows you to find those things electrically. So it still is an electrical field solver that just measures the coupling between every trace in the design. And with this, you can choose to create a directed group, which more or less asks you to define different drivers and receivers in the design. And once you create those directed groups, it will give you additional data as an output. So it's not mandatory to set up directed groups, but if you do, you'll get additional data, which I'll show you in a second. So once you set up the analysis modes and the nets you're interested in, you then start the analysis, which again, in a design like this, it would maybe take 3 to 4 minutes to run. And let me load my analysis results. So now what you're getting is the same color-coded overlay showing you the coupling coefficient. How much coupling do you have between nets, which, if the nets are going to be active at the same time, indicates you're probably going to have a crosstalk problem, right? So again, you can color code this to find the highest or worst case offenders in the design. You can look at worst case, or you can look at victim net. So worst case just shows those are the segments that have the highest amount of coupling. Victim net shows you the nets that have the most amount of coupling on them from other nets in the design. And so again, you can use these visuals to find the nets that maybe you need to spread apart, reroute, stuff like that. And also you have the coupling tables, which again are going to show you the nets, the aggressor, the coupling coefficient, the length with that coupling coefficient, and the coupling index. So if you wanted to find the net that has the highest coupling coefficient, you could find that there. And then you can navigate in to find those particular trace segments in the design that have the highest coupling coefficient. Okay. And if you look at that in terms of directed group, what that is going to also give you is additional plots. And I should mention that, for example, if you zoom down here and you see that particular net has a high amount of coupling coefficient, those other traces are on different layers. So this is not just same layer coupling, this is Z-axis coupling as well. So if you use directed group, you are also going to get these different coupling plots. Let me kind of make this a little bit bigger here so we can see all of it. All right. What these coupling plots are showing you is in this bar expanded plot, it's showing you every net in the design, and these lines here represent the length of that net. So this is a rather long net as compared to that net. And the colored areas show you the amount of coupling at the different lengths in the design. So for example, this net has no coupling, then a small amount of coupling, no coupling, small amount of coupling. And so you can quickly scroll through this design to see, for example, this net's very short, but it has a high amount of coupling. That may be a problem. This net has coupling throughout almost its entire length. That could be a problem. This net may be okay. So that's how you can use the coupling plot. And again, you can double click from these things to navigate to that part in the design. Or you can look at it as a scatter collapse plot. So this is just going to take, put the highest coupling lengths here, middle coupling, lowest coupling. And again, if you want to find where those are at in the design, you can double click on that and it'll take you to that particular location in the design. So that's impedance and coupling vision. All right, let me go back to another layout and show you two more final features before I finish up. Another subtle feature that we've added, but highly popular, is this cut traces command. This can be very popular when you're reworking something or doing an ECO. So for example, let's say this design is getting an update and these memory modules all need to be replaced, right? And so you're going to kick these footprints out and pop in some new footprints. You want to keep all the routing around here. So you can go into this cut trace command and just draw cuts through all these traces around this component. And then now you very easily can move this component out, keep the existing traces, plop the new component in, and then reroute from the existing traces to where that component is. That makes ECO processes a lot easier. And then the final new feature I'm going to show you before we kick it over to Q&A is the new shape engine. Similar to the move command, when you go into the add shape engine, you have three different modes: polygon, rectangle, and circle. I'll show you this in the polygon mode. So in the polygon mode, when you start drawing a polygon, notice you get a heads-up display showing you the length and the angle that you're working with. And notice you have some little helper shortcut keys in that command window. So right now, the angle is free. I can draw at any angle I want. If I use the shortcut key that it tells me, now I'm locked to transitioning at 45-degree angles. I use A again, now I'm at 90-degree angles. Go back to A again, and now I'm at any angle. So say I want to stick to 45-degree angles. So you can draw, click a vertex, draw, click a vertex. And then now notice while it's drawing again, you have more heads-up display showing you anytime you have parallel segments or perpendicular segments while you're drawing. Let me show you these two other draw modes. While you're drawing, if you want to draw a arc-based corner or a inline arc, if you use the Q key, you now have an arc-based corner showing you the radius and the angle of the arc-based corner that you're drawing. So maybe you want a 45-degree corner. If I put the angle lock there, then it's only going to let me draw 90-degree angle corners in the design, and then you can just specify how big you want that 90-degree angle corner. Click there, cycle back to Q. Now I'm drawing a line again, drawing a line, drawing a line. Going to come over this way, and I'm going to use the Q key to cycle. Now I'm doing this inline arc. So now you can very easily see if you want an inline or outline arc, how big that arc is and what the radius of that arc is. So if you need to have a cutout or something like that of a certain size in your design, that makes it very easy to get that. And then I'm going to cycle back with Q, and then I'm back drawing a line. So with this drawing tool, you get a heads-up display showing you the length and the angle in very easy modes to cycle between the different drawing types. So that concludes my demo. Hope you designers saw a couple things that you like. Appreciate your time. Let's go to Q&A.
All right. Thanks, John.
Yeah, no problem.
We should just have a couple minutes for Q&A here. Let's start with going back to what we talked about towards the beginning is what is the difference between LiveBOM versus CIS Part Manager? Nathan, you might be best positioned to answer that.
Sorry. So CIS BOM and Part Manager is Live BOM and
CIS
CIS.
Part Manager and LiveBOM, yeah.
Yeah, so Live BOM is basically once you have completed your design, so all the components that you have on your design, you will have their supply chain information fetched from the source engine website. So you can view the availability, the part risk, and inventory and forecast and all. Part Manager is basically where you manage your part with respect to the part database. So basically, once you have completed your design, whether to check whether everything is in sync with your database, so use CIS Part Manager for that. In order to basically generate BOM and ensure that everything is available, you use Live BOM.
Okay. Next, is PSpice available in Linux?
Not currently. No.
Okay. Okay. How do I switch between OrCAD Professional and OrCAD X Pro?
OrCAD X Professional and OrCAD X Pro. So
OrCAD Professional to OrCAD X Pro.
okay, for that, so OrCAD X OrCAD X Pro gives you additional cloud-based capabilities. So for that, you need to register and get an cloud activation. So for that, you need to log into Cadence portal and then basically register and buy a SQL license for that. Yeah.
And all right, does the InDesign analysis feature still require a separate Sigrity install to activate, or is it included in the OrCAD X installer?
It still requires a Sigrity install. Unfortunately, we recognize that it should be included. Our challenge there is there's so many Sigrity engines involved, and maintaining the two in one singular install has proven challenging.
All right. One other popular question we saw was about the source of the data that was in the LiveBOM portion. Maybe we could address that real quickly.
So okay, so that is coming from a source engine. So the LiveBOM has inbuilt a connection, or basically it is data is fresh from source engine and data link, which is basically its analysis is part of source engine for the MPN information that we get. So you can equivalently also see the information on source engine website, but within the capture interface, you can get that from the LiveBOM itself.
I think that's all we have time for in terms of Q&A. Thank you.